All right, in this explainer, we are diving deep into what is, without a doubt, the gold standard for connecting a big company to the AWS cloud. This isn't just some theory, this is the proven, professional level stuff used by the biggest names out there. So let's get right into it. It's a really important question, right? I mean, we're talking about incredibly sensitive, mission-critical data. It needs a private, super fast, and rock-solid highway into the cloud. The answer? Well, it's in a powerful combo of services that really forms the backbone of modern hybrid cloud networking. So here's our game plan. We'll kick things off by laying out that gold standard architecture. Then we'll actually follow the data to see how all the pieces fit together. After that, we'll look at how to scale it globally, how to master the traffic flow, and maybe most importantly, cover the critical mistakes to avoid. We'll wrap up by showing you this seriously powerful architect-level toolkit you're going to have by the end of all this. Okay, first up, the enterprise gold standard. And I really want to stress this. This isn't just one of many ways to do things. For any serious, large-scale deployment, this is the blueprint. This is what AWS recommends. So here it is, the fundamental stack. It all starts at your own on-premise data center that connects out through a private Direct Connect link, which lands on a Direct Connect gateway. That gateway then hands everything off to the absolute heart of this whole setup, the transit gateway. And from there, it just fans out to all of your individual VPCs. Those little isolated pockets of the cloud where your apps actually live. Just think of the transit gateway as the central nervous system for your entire cloud network. So why is the transit gateway such a big deal? Well, because it's so much more than a simple router. This thing is a massively scalable hub. It can connect thousands of VPCs, it can manage traffic across different regions, and it gives you this incredibly fine-grained control over all your network routes. It's kind of like the central airport that connects your private Direct Connect, your backup VPNs, and even your SD-WAN solutions all into one single cohesive network. It's just way more flexible than the old ways of doing things. Okay, so we've seen the blueprint. Now let's actually see how it works. Let's follow a single packet of data on its journey, all the way from a server in your data center to an application running in the cloud. Okay, so the flow is what's really important here. First, your router on-prem establishes a connection using BGP. That's the Border Gateway Protocol, basically the routing language of the internet, with AWS. Your data then travels over that private fiber line and arrives at the Direct Connect gateway. From there, it crosses a special link, we'll talk about this in a sec, called a transit VIF to get to the transit gateway. The TGW then does a quick lookup to figure out where the data needs to go and forwards it to the right VPC. See? Every step is a nice, clean handoff. I mentioned a key term there. The transit VIF, or virtual interface. This is the magic link. It's the secure, high-speed, totally private bridge that connects the world of your Direct Connect to the world of your transit gateway. You really have to get what this component does to understand the whole picture. It's that fundamental. Now, let's talk about one of the most powerful parts of this whole design. We're going to take this concept and use it to build a truly global network. And believe it or not, we can often do it from just a single physical starting point. And this is just a brilliant illustration of the power of the AWS global backbone. Get this, you could have one single physical Direct Connect circuit that plugs into a data center in, say, Toronto. But from that one connection, you can attach to transit gateways in Virginia, Oregon, and even Tokyo. You don't have to run fiber across the ocean. You just plug in once and let the AWS network handle all the heavy lifting for you globally. This is what it looks like in a real-world, high-availability setup. You've got two data centers, your main HQ and a disaster recovery site. Both of them are feeding into that Direct Connect gateway, which then connects to that central transit gateway hub. This setup lets you do an active model for load balancing or an active standby for instant failover. It's just robust and resilient right from the start. All right, so we've built the network. Now it's time for the masterclass. This is where we get into the really cool stuff. How architects use advanced routing tricks to get pinpoint control over exactly how and where their traffic goes. So, a classic requirement for any big company is automatic failover. The way it's done is actually pretty simple, but really powerful. You set up two paths to the cloud, your primary, super fast Direct Connect, and a backup path, maybe over a VPN. Then, using a technique called AS path prepending, you basically tell the network, hey, this main path is shorter and better, always use it. But if that main link ever goes down, traffic automatically switches over to the longer backup path. It's just elegant, and it works. Now, BGP community tags, think of these like little sticky notes or special instructions you can attach to your network routes. So for example, you can use a specific tag to tell AWS, hey, only announce this route to my private transit gateway, or maybe to a public zone. Or, and this is super useful, you can tag a route as a black hole, which basically tells the network to just drop that traffic. This gives you an incredible amount of granular control. Okay, this next part is one of the most important. I mean, learning the design is one thing, but avoiding the common mistakes that can take down your entire network is another thing entirely. Let's go through them because these are the crucial lessons that people have learned the hard way out in the real world. First things first, Direct Connect is a purely private service. It does not support Network Address Translation, or NAT. You know, the tech that lets a bunch of devices share one public IP? Yeah, can't do that here. This means all your communication has to use unique private IP addresses. If you get this wrong, your servers on-prem just won't be able to talk to your stuff in the cloud. Simple as that. Second, you have to be really careful if you're dealing with older network designs. Traffic coming over a direct connect cannot get to a VPC that's connected to your network using VPC peering. If you try to do this, you basically create a black hole where your traffic just vanishes. The transit gateway is the modern way that solves this, so it's really best to just use it from the get-go. Third, routing isn't magic. Just because your transit gateway learns about a route from your data center, that doesn't mean your VPCs automatically know about it. You have to explicitly configure the route tables in both the transit gateway and in the individual VPCs. If you don't, traffic from your data center just won't have any idea how to get to your applications. And finally, this is a huge one, especially during migrations: overlapping IP addresses. The IP ranges you use in your on-premise network cannot, under any circumstances, overlap with the IP ranges in your VPCs. If you ignore this, oh man, you're going to be forced into a really complex and expensive redesign project. So careful IP address planning from day one is absolutely essential. So after navigating all of those pitfalls, let's end on a high note. Let's just summarize the powerful professional-level toolkit that you've just unlocked by understanding this architecture. So let's just recap what this blueprint lets you do. You can now design a true hybrid cloud that connects multiple data centers. You can build in multipath redundancy and automatic failover. You can use a single connection for multi-region connectivity. You can implement advanced routing policies for traffic engineering and isolation. You now have the blueprint for enterprise-grade hub-and-spoke cloud networking. And I'll just say this directly. You now have the foundational knowledge to design these exact architectures at a level that's on par with an AWS Solutions Architect Professional or even a Cisco CCIE. This is the core skill set that really separates the pros. But, you know, technology never ever stands still. We've mastered these building blocks, but what's the next evolution? How do you manage a complex global network like this even more easily? Well, the answer is in unifying all of this under a single control plane with a service called Cloud WAN. And that, well, that's a story for our next explainer.